Okay, so you'll need a sheet of graph paper. We're going to be working on page S.170. It's a lesson 25, and we're going to be looking at the graphs of systems of equations. So on number 1, it says sketch the graphs of the linear system on the coordinate plane. And then it gives us these two equations. Y equals 1/3 x plus 1, and y equals negative 3x plus 11. So now I'm going to draw my coordinate plane, and I'm going to draw it to where it takes up a good bit of the page. So this is my y-axis and this is my x-axis, for those of you who don't remember. And we're going to start with the first equation. If you look at the first equation, they have a +1 on the end of it. That means I'm going to put a point on the y-axis where 0, 1 is. So here is 0, 1, and I'm going to put a point. Now I'm going to go to my slope, which is in front of the x, which is 1/3. Since it's 1/3, it's positive on the numerator and denominator, which means I start at the 0, 1, the y-axis. I go up 1 and to the right 3, and I put a point. Go up 1 to the right 3 and put a point. Up 1 to the right 3 and put a point. Up 1 to the right 3 and put a point. And you would continue until you can't go anymore. When you've reached all you can go back to the y-axis, and we're going to put it in reverse. We're going to go down 1 to the left 3 and put a point. Down 1 to the left 3 and put a point. Down 1 and to the left 3 and put a point until you can't go anymore. So now you have dots, so you can kind of sketch you a line by connecting the dots. I'm just going to lightly connect my dots. So that's my first equation graphed. Now I'm going to go to the second equation. They have a +11 on the end. That means on the y-axis, my y-intercept is 0, 11. So I need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is actually where my point will be. So that means I have to extend my y-axis. So you should have a point on 0, 11. Your slope is a -3 over 1. That means I need to start at 0, 11 and go down 3 to the right 1. So I count 1, 2, 3 to the right 1 and put a point. Down 1, 2, 3 and to the right 1 and put a point. Down 1, 2, 3 and to the right 1 and put a point. Down 1, 2, 3 and to the right 1 and put a point. So I'm going to keep going until I reach the end of my coordinate plane. So down 1, 2, 3 and to the right 1 and put a point. Down 3, right 1, down 3, right 1, down 3, right 1. If you connect your dots, you should see that it makes a line. And so now we can clearly see our point of intersection. So our point of intersection is right here. And so part A says to name the ordered pair where the graph of the two lines intersect. That would be 1, 2, 3 and up 2. So 3, 2. Part B says to verify with the first equation that this ordered pair is correct. So we have y equals 1/3 x plus 1. In the place of the x on the y, I'm going to put an open set of parentheses. And now I'm going to insert my x and y that I just got from my point of intersection. In the place of the y, I need to put a 2. In the place of the x, I need to put a 3. That leaves me with 2 equals 1/3 times the whole number 3. To make it into a fraction, I need to put it over a 1. 1 times 3 is 3. 3 times 1 is 3. 3 divided by 3 is 1. So I get 1 plus 1. 1 plus 1 is 2. So 2 does equal 2. So I verified that this ordered pair does work for this equation. So now, part C, it says verify that the ordered pair named in part A is a solution for this equation. Y equals negative 3x plus 11. In the place of your x and your y, you're going to put an open set of parentheses. In the place of the y, we're going to put the 2. In the place of the x, we put a 3. So we'll get 2 equals negative 3 times 3 is negative 9 plus 11. So negative 9 plus 11 is 2. So 2 does equal 2. So that means this ordered pair works for this equation as well. So that is number 1. I'm going to turn my graph paper over and I'm going to write number 2. It says find the point of intersection, or sketch the graphs of the linear system on the coordinate plane. And so the first equation is y equals 1/2 x plus 4. Second equation, x plus 4y equals 4. So I noticed right away that my second equation is not in slope-intercept form. It's in standard form. So I need to change it to slope-intercept form. Step 1 is subtract the x from both sides. I have x minus x, which is 0. So I get 4y equals negative x plus 4. Step 2 is to divide by the coefficient of y, which is 4. Each term is divided by 4. So I will just get y equals, in front of this x and in back of this negative, there is a 1. So it's really negative 1/4 x plus 4 divided by 4 is 1. So here is my equation in slope-intercept form. So I need this equation and this equation for my system. So I'll rewrite those right here so I don't get confused. So now on my graph paper, I'm going to write my coordinate plane. And I'm just going to trace it through my paper because I can see the one I drew on the other side. Here's the y-axis, here's the x-axis. So now I'm going to start with the first equation. I see that I have a plus 4 on the end of the equation. That means I start on the y-axis at 0.04. Here's the origin, so I count 1, 2, 3, 4. So here's 0.4 on my y-axis. My slope is 1/2. So from 0.4, I'm going to go up 1 to the right 2, up 1 to the right 2, and I'm going to continue up 1 to the right 2 until I'm off my coordinate plane. Then I'm going to go back to the y-axis. I'm going to go down 1 to the left 2, down 1 to the left 2, down 1 to the left 2, and I continue until I get off my coordinate plane. So then once you have all of your dots, you can connect your dots and you should get a line. the second equation, they have a +1 on the end. That tells me I start on the y-axis at 0, 1. So I go to the origin, and I'm going to go up 1 and put a point because that's where 0, 1 is located. My slope is a -1/4. That means I'm going to go from the point 1. I'm going to go down 1 to the right 4. 1, 2, 3, 4, and put a point. Down 1 to the right 4. 1, 2, 3, 4, and put a point. Down 1 to the right 4 and put a point until you can't go anymore. I'm going to go back to the y-axis. I'm going to go in reverse. Up 1 to the left 4. 1, 2, 3, 4. Up 1 to the left 4. 1, 2, 3, 4. Up 1 to the left 4. 1, 2, 3, 4, until I can't go anymore. Now you can connect your dots. And you should have a line. And remember, this is your point of intersection where they cross. So part A says to name the ordered pair where the graphs of the two linear equations intersect. So that's going to be 1, 2, 3, 4. That's -4 because it was to the left 4. And 2 up. So my ordered pair is -4, 2. Part B. Verify that the ordered pair named in part A is a solution to this equation. Y equals 1/2 x plus 4. So in the place of the y, I'm going to put parentheses. Also in place of the x, I'm going to put open parentheses. For the x and the y, we just got that ordered pair. So in the place of the y, I'm going to put a 2. In the place of the x, I'm going to put a -4. I'll get 2 equals 1 times -4 is -4. 2 times 1 is 2. -4 divided by 2 is -2, and then I have a +4 on the end. -2 plus 4 is 2. So 2 does equal 2, so I know that this ordered pair works for this equation in part B. For C, it says verify that the ordered pair named in part A is a solution to this equation. X plus 4y equals 4. In the place of your x and y, we're going to put an open set of parentheses. In the parentheses, in the place of x, we're going to put -4. In the place of y, we're going to put 2. So I get -4 plus 4 times 2 is 8. And that's going to be equal to 4. So I know -4 plus 8 is equal to 4. So yes, 4 is equal to 4. That's a true statement. So we verified that this ordered pair works for this linear equation. So now that you see that we've done 2 problems, we're going to ask you to do number 3, 4, 5, and 6, each on a separate sheet of graph paper. So you can do front and back, and then you should be done. When you're done, you can turn it in. Thanks for watching.